Hello friends, this is Prof.Dattu Patel from LJ Institute of Engineering and Technology. Earlier lecture, we already learned about vector calculus, higher order ordinary differential equation. Today's session, we start with our new unit, that is Laplace transform. First of all, we start with definition of Laplace transform. Simple word, transform means we convert one form to another form. Here we can say that Laplace transform, that is difference between S, that is depends on S domain and T domain. T means that is time domain. We convert time domain to S domain, then we can say that it is Laplace transform. S domain to T domain, then we can say that inverse Laplace transform. Let's start the definition. Let f of t be a function defined for all t greater than or equal to 0. Then the Laplace transform of f of t is denoted by a Laplace of f of t or f bar of s or capital F of s, and is defined as, this formula we must be remember, that is the definition of Laplace transform. L of f of t equal to integral 0 to infinite e raised to minus st f of t dt. This formula we use to solve the examples and some elementary functions. Let's start with examples. Depends on Laplace transform. Definition of Laplace transform. Example. Find Laplace transform of given function f of t equal to 3 or 0, where 0 less than t less than 2, here t greater than or equal to 2. Means this type of function we can say that is a piecewise continuous function. Our Laplace transform range is 0 to infinite. Means according to this shape, function have a value 3, here 0, function amplitude is 3, value is 0 to 3, 0 to 2, means 0 to 2, we have function has a 3 value, and t greater than or equal to 2, we can say that it is 0 up to infinite. Means this particular range we can say that function has 3, remaining this value we can say that function has a 0 value. Means this particular function which is divide, then we can say that our function is a piecewise continuous function. By Laplace transform, by definition of Laplace transform, that is Laplace of f of t equal to integral 0 to infinite e raised to minus st f of t dt. Here we break the limits. Means 0 to 2, function has a 3 value. Means 0 to 2, f of t equal to 3, means 3 into e raised to minus st dt plus 2 to infinite. Function has a 0, means 0 into anything 0. Then we find 3 constant, 0 to 2, e raised to minus st, here 3, e raised to minus st by minus s, 0 to 2, then upper limit minus lower limit. Then we can find here minus 3 by s, e raised to minus 2s, minus here t into 0, 0 into anything 0, minus e raised to 0, e raised to 0, 1, anything raised to 0, 1, then we get minus 3 by s, e raised to minus 2s, minus 1, minus comes inside the brackets, then we get into 3 by s. That is the Laplace transform of this function. Another example. next example. Find Laplace transform of the function f of t equal to sin t, here 0, and limit, that is the range of t 0 less than t less than pi, here t greater than equal to pi. In this example, first 0 in range of t 0 to pi, function is a sin t. If range of t greater than equal to pi, function has a 0. According to the definition of Laplace transform, Laplace of f of t 0 to infinite e raised to minus f of t dt. Now here breaks the limits, then 0 to pi e raised to minus st function sin t dt plus pi to infinite, function is a 0, 0 into anything 0, then 0 to pi e raised to minus st sin t dt. Then in this topic means that is value of u, that is value of v, product rule. Then in this formula we cannot use directly product form. Then we already learned the basic two formulas in 12th science, that is e raised to ax cos bx, then we get e raised to ax upon a square plus b square, a cos bx plus b sin bx. Similarly, second one formula is e raised to ax sin bx dx equal to e raised to ax upon a square plus b square, here sin, then sin is negative, a sin bx minus b cos bx. If here it is sin, then first we use sin, and sin is negative sign. If here cos, then we first cos then sin, and cos. Here middle term has a positive. Then here a equal to minus s and b equal to 1. Then e raised to minus st upon minus s square plus 1 a sin t minus 1 into cos t. Here 0 to infinite, upper 0 to pi, and second term which is 0, 0 into anything 0, means upper limit minus lower limit, then e raised to minus s pi upon s square plus 1 minus sin any pi 0 minus cos pi, that is minus 1 minus e raised to 0 1 upon s square plus 1 sin 0 0 minus cos 0 1. Then here minus 1 minus minus plus, then e raised to minus s pi upon s square plus 1 minus minus plus 1 upon s square plus 1, then denominator which is common, then we get s pi plus 1. Similarly, if here cos t, suppose, then same as just to be at this particular position, we use this formula and we get the answer. Means here first definition of Laplace transform, here function is a cos t, then e raised to minus st minus s square plus here cos, and first a equal to minus s cos t plus b 1 into sin t, here 0 to pi, upper limit minus lower limit, e raised to minus s pi s square plus 1 minus s cos pi minus 1 sin pi 0 minus e raised to 0 1 upon s square plus 1 cos 0 1 plus sine 0. Then we get minus minus plus, then s into e raised to minus s pi upon s square plus 1. Minus minus plus, again s upon s square plus 1. Then s upon s square plus 1, that is common, e raised to minus s pi plus 1. Next example. Find the Laplace transform of, suppose here function is t, here 0, here range is 0 to t to 2, 1, that is easy for simplification, t greater than equal to 1. Then here first for definition of Laplace transform, integration 0 to infinite e raised to minus st f of t dt, then breaks the limit, then we get 0 to 1 function, that is e raised to minus st into t plus 1 to infinite function, that is 0 into anything 0. Then according to this formula, with the help of Lied, means that is the algebraic term and that is the exponential term. Then according to the Lied, we first write algebraic, then t into e raised to minus st dt. Then with the help of Bernoulli's equation as well as integrating by parts, anyone you can choose for solving this. We use Bernoulli's equation, that integration of u dx, then u as it is, integral of v1 minus derivative of u, integral of v1 plus u double dash v3 u triple dash v4 and so on. That is the formula of Bernoulli's equation. This formula we use at particular position and we get u as it is, that is value of u, that is value of v. Then u as it is, e raised to minus st by minus s, integral of v minus derivative of t, then 1 integral of this term, then e raised to minus st divided by minus s whole square, here 0 to 1 plus derivative of 1 0 into anything 0, then upper limit minus lower limit, then e raised to minus s by minus s minus e raised to minus s by s square minus 0 into anything 0 minus e raised to 0 1 upon s square. Then we get e raised to minus s by minus s minus e raised to minus s by s square minus minus plus, then 1 upon s square. And first and second term, that is e raised to minus s minus with sign common, then 1 upon s plus 1 upon s square and plus 1 upon s square. That is our answer. If you have any doubts regarding this topic, then feel free contact me. Thank you so much.